Hi, my name is Dr. Margaret Mary. Today we are going to discuss about the Apriori algorithm. What is Apriori algorithm and how it is going to be executing with the example? With the example we will check. What is Apriori algorithm? Apriori algorithm is given by R. Agarwal and R. Srikanth in 1994 for finding frequent item set in data set. It is very important for the association rule mining. The name of algorithm is a priori because it is use a priori knowledge of the frequent item set, and we can say that item set property. So we can apply a iterative approach or level wise search where k frequent items are used to find k plus item sets. This algorithm is play very significant role in data mining technique, especially association rule. So Apriori is an algorithm for the frequent item set mining and association learning over the relational database. It is going to be proceed by identifying the frequent item set, means it is going to identify individual item sets in database existing them to large item set as long as those item sets appear frequently often in the database. So just if you're going for any shopping or any mall, we want to identify which are the most item very frequently is taken by the customers. We want to identify that. So more customers is going to take the particular item, so that item we can call as a frequent item sets. So determined by a priori can be used to determine in association. So this is a rule. This is the one in the real-time application, especially market basket analysis. So we will go to one example. I will explain you how the Apriori algorithm is working. So with the example, first we will go for the data sets. See, this is the first example. So you can see that TID and item. ID is a transactions, that is a transaction ID. So totally we are taking as a 4 transactions. The one transaction you can call it as a one basket. The one customers is purchasing item 1, item 3 and item 4. If the second person, that is ID is 200, is purchasing, it is taking 2, 3, 5, and third person is taking 4 items, that is you can call as a 1, 2, 3, 5, and the fourth one you can say as 2 and 5. This is a data sets. This is the data sets, that is each person it is taking a one means one person is taking a 3 item, second person also taking a 3 item, fourth person also taking a 4 item, and fourth person is taking a 2 item. Now we will start the Apriori algorithm. How we are going for the Apriori algorithm? So now you can scan from that. How you are going to scanning? This is the first rule. How it is? So whatever the data sets, that is first you have to identify how many data items are there. 1, 2, 3, 4, 5. So all together we have a 5 items, that is first item person is taking the item 1, 3, 4, and the second person is taking 2, 3, 5. So like that you are going to be scanning. 1 is how many times it is there. So you can see that it is a 1 is year 1 and year. So that is 2 times. Next, if you go for the second, you have to see 2 how many transaction is taking place. Here is 1, 2, 3. So it is 3 times. Next we'll go for the 3 also 3 times, and 4 is only 1 time, that is the first transaction the person is taking the only one time. So 5 is 3 times. So now this is one iteration, means one procedure is done. Okay, so now we'll go for the Next one, what is that? Here we have to put it as a threshold. What is the threshold? Less than 1. Those who are having less than 1, we are going to be pruning, or you can say as a eliminate. You have to terminate, or you can take it out from the table. So as 4 is having only 1, we want to remove that. So you can see that 1 is 2, 2 is 3, 3 is 3, 5 is 3. So 1 is removed. Okay, so 1 is removed. So next procedure will go. What is the next procedure? The first one we taken as an individual item. First we identify, we calculated each one how many transaction is taken place. Next we tried, we put a threshold saying that those who are having only one time we removed from the table, and we done, which is the after the 1 removed, what is the table? That is 1 is 2 time, 2 is 3 time, 3 is 3 time, 4 is eliminated, 5 is 3 time. Now we are going for the 2 time. So we have to generate, each time we need to generate this tables. So now what you have to do it, we have to make it as, leave it as a support. We are means support, no, whatever item set, that 1 to 2, 1 to 3, 1 to 5 combination. First is 1 time, second we are going 2 to item set combination we are going to make. So 1 to 2, 1 to 3, 1 to 5. Okay, next 2 to 3, 2 to 5. Next 3 to 5. So after that we cannot make it any other combination. Now we have to check with this. This is the actual transaction. Then you see that 1 to 2 how many times are there. The first transaction 1 to 2 is not there, and the second transaction 1 to 2 one time it is there. Again you check it 1 to 3 how many times. See, first transaction 1 to 3. Again you can see third transaction 1 to 3. Again 1 to 5. 1 to 5 only one transaction. 2 to 3, that is one transaction, 2 transaction. 2 to 5, one transaction, 2 transaction, 3 transaction. 3 to 5, one transaction, 2 transaction. So now we have to check it what it is. So now again after the generating, then we are comparing with the whatever the actual data, whatever the data sets we have, we need to compare whatever we generated the data sets tables. So now again we are applying the threshold. The threshold will be 1. Okay, so that is the 1. So whatever the transaction 1 time, 1 5 is 1 time, remaining 1 3 is 2 time, 2 3 is 2 time, 3 5 is 3 time, 3 5 is 2 time. So now 1 you remove, then you are going to get 1 3 is 2 time, 2 3 is 2 time, 2 5 is 3 time, and 3 5 is 2 time. So this is the data sets arrived. Okay, so each and every time a priori algorithm, whenever we are doing, first we have to go for individual number, then we have to check what is the supports are available, then we have to go for the 2 data sets, means 2 type of the item we have to compare. That 2 item, those who are transaction, how many times the frequent is happening, according to the support we have to generate the item. So 2 is generated, so we got the support also, where all the 1 is there we removed. So 1 2 is 1 time we removed from that, and 1 5 is that is also we removed. Now 2 is over. Now we have to go for the 3 combinations. What is the 3 combinations? You have to go for 1 2 3 2. That is one combination you can go. Okay, and otherwise you can go for, you have to identify. See, when you can go, see here we taken that, you can see that 2 3 5. Okay, so before going for 3 you can check it, we have a 3 transaction, only 3 item. 1 3 4, it is 1 time. Okay, but you can see that 2 3 5 is 1 time, 2 3 5 is 2 time. So only it is going to give a support more in this when you make it as a 3 combination. It is a very easy, because we taken only 4 transactions. To make you to understand what is the a priori algorithm, we taken only 4 output. So in this 4 output means 3 transaction, we have only 4 transactions. So in that 4 transaction, means we can see that very clearly 2 transaction it is happening 2 times, that is 235 2 times. Then remaining 134 it is 1 time. If you take the combination in this way, so if it means whatever the combination if you take, it is coming for the 1 time. So directly we can go for the support 235. Okay, so at last the 235 is coming for the 2 times. Okay, so here I am not explaining about the conditional formatting, just I want to help, means I want to tell you that what is the a priori algorithm, how simple you can be identify. Okay, now we'll go for the a priori algorithm limitations. When you taken as association rule, in the association rule 2 algorithm is a very important algorithm. One is the a priori algorithm, the second one is FP growth, frequent pattern growth. So before first we are doing as association rule, in the association rule we are going to see as what is the support, what is the confidence, and what is the lift. Then we have a type of the association rule, that is the first one is a priori algorithm. So a priori algorithm, with example I explain how we want to generate the table. In that how to identify the support is a very simple support, that is when we have to keep it as a threshold. We have to identify how many transactions are doing, depends on that you can fix the threshold. Okay, so if before going for the FP growth, why the a priori algorithm having a limitations? What all the disadvantages? The first one, a priori algorithm is very slow, because as I taken as a 4 transaction, first one individual transaction, after you have to go for the 2 transaction, then you have to go for 3 transaction. As a 4 transaction is happened, so it is very easy to identify which is the one is giving a more support. The same thing when you're going for the 6 transaction, again and again you have to identify, you have to generate the table. According to that you have to do it the support. So the first limitation is very slow. The main limitation is time required to hold the vast number of candidates set to much frequent item sets. Even though it is support is 1, again we have to create, we have to make it, we have to show that this is not having a sufficient support, it is not having a, to go for the next table it is not having a support, so we have to create it. So that is the example here I given, because low minimum support large item sets we have to create. If suppose as a 4 we go, it is okay, but if we go for the under the power means 2 to the power 100 candidate item sets, it is going to take a long time, as well as it is going to take a more space, so it is not efficiency. So we have to identify when the association rule when identifying which is the algorithm is going to give a best. The best is going to be identified with the help of the space and time. But a priori algorithm first means it is taking lot of time, and again we want to generate the tables or again and again generate the data sets. So then we have to identify the support, then we have to remove, again you have to create it. So it is take a time. A priori will be very low and inefficient when the memory capacity is limited with a large number of transactions. So that is the one I'm going to tell you, that it is going to take a very low and inefficiency when the memory capacity is limited with a large number of the transaction. So next FP algorithm we are going to study. So now for this I am going to stop. Thank you.